Okay, so using Python for machine learning jobs. So questions you could have are which machine learning tools are installed at HPC2N and UPPMAX, or indeed at the various HPC centers in Sweden? How do you use the tools? And how to deploy GPUs at HPC2N and UPPMAX? And the third one has already mostly been answered by Pedro, of course. But I will talk about it only in regards to the machine learning tools. Okay, so let's first have an overview of what tools are installed, and then look at how to use it with Python. And there will be a few demos and code alongs. And as I'm sure you know, even if Python is maybe not the fastest language, it is well suited for machine learning. It's quite easy to code in, and that is a useful feature in machine learning because you rarely have the right solution from the start and have to make changes regularly after tests and experimentation. So there will be many iterations of your program. Also, another important thing is that there are a lot of useful libraries written for machine learning in Python, and that I think is probably the most important reason why Python is popular for machine learning. Some of the most used libraries in Python for machine learning are PyTorch, scikit-learn, TensorFlow, and these are all available at both UPPMAX and HPC2N, and as far as I know, they are available at all the HPC centers in Sweden. I have a number of exercises, and I will look both at PyTorch and TensorFlow, but also at some other ones. And there are some links here with some more information that might be interesting for those who wants to know more. So I will look again at the pandas and matplotlib example that you looked at in the load and run Python section. And there you ran it directly and saw how you got a plot on the screen. And maybe you also ran the batch job. In any case, if you want, then you can try it again here. And I'm just going to go through it very quickly. So this is how it looks. And the things that are commented out are, as Björn mentioned back under the load and run section, that is what is needed if you are on Kebnekaise. So if that is the case, then you remove this out commenting hashtag thingy. And as a batch job, it would look like you would run this Python script. And the difference here is, you can see here it's plot show, and here it's plot save pick. So, okay, I will go and look here in the sections here. And I think I'm going to remove some of these Slurm output files because they are taking up a lot of space here. In any case, to run this, I will see if I can find the example somewhere. Where did I put it? Let's see. It's weird, I had it. Anyway, let's see if I have it here. It may be, well, let's copy it. Let's do that. And then I will create job script. I think actually I may have put it in the wrong place. I just need to go check what is under the program directory. No, that's fine. weird. I may have forgotten to actually add it to the Git repo. In that case, I'm going to place this script here.
Apparently, you can find it if you did the Git clone instead.
I had probably, I think I did a copy on UPPMAX, so I shouldn't have done that. Let's go back. Let's clone it, and I'll do a new pull.
Yeah.
It's not there, I think. Well, nothing wrong with just removing it and creating a new one, a new copy of it. That is always an easy way of making sure you have what you want. Like that. Let's clone it again. It's here.
That way.
It's weird, it's still not there. Okay, never mind then. Let's just create it. Okay, now I have the full path here, and everything else looks correct. So I should be able to run it. It has already run probably. Let's look at it. Yes, it has. And the output is here. And there will probably not be anything in it. Let's see. Why HPC Python? HPC Python exercises, examples, programs. What did I call it? Pandas matplotlib batch rack. Okay, it's pending. Running. Completing. And it says run. Good. And here we have the output. Let's see if it worked this way. I need to set the path. I'm going to instead change to that directory and copy the batch script there. I still don't understand why it is not there, because I was sure I added all of them earlier.
So in the batch script, maybe you should do change directory as well, or set the full path to.
Yeah, I set the full path.
Yeah. Yes, but okay. Yes.
But now but
then
it
in the
didn't see the
script,
path
no.
to the Scottish Hills one, so now it does.
Mm.
But it may well be that they are just sitting in my home directory and I haven't added things to the GitHub, but I don't understand why, because I was sure I had. Such things happen. It has run. Let's see. And now you can see this is the output. There's nothing in it, as there shouldn't be, because the output went into myplot.png.
Oh.
As it should. So that is fine. So that worked. And because I haven't logged in with X11 or anything, I can't actually open it right now. But otherwise, you could open it on UPPMAX with EOG and on HPC2N with EOM. But yes, I would suggest the simple way, since I didn't add it here, is to go to the programs directory and then just copy this here and create a file with that in this directory here in programs. So if you are on Rackham, just copy this and put it in some file, and you need to add -Rackham here also after this, because that's what I called it here. See, this one. So that is what should be here. And for the HPC2N one, that is correct. I will go and update this as soon as I have finished talking here. And try to figure out where this actually ended up, if somehow it has gotten deleted again. Anyway, let me continue with the PyTorch example. PyTorch has an n-dimensional tensor similar to NumPy, but it can run on GPUs. And there is automatic differentiation for building and training neural networks. And the example here has taken from the official PyTorch page, and you can go there and find more examples if you want to. And this is the Python script. It looks like this. And it is named like that in the programs directory, so you can find it there. So in order to run it, you need a batch job, and to run it either as a batch job or to run it interactively. Because you shouldn't run it on the login node, and also there are no GPUs there. So because of that, it has to be run on the compute nodes. And this is an example script for HPC2N. And this one should be here. Let's go to the UPPMAX directory and the HPC2N directory. And that is there. It's called PyTorch fitting GPU, and .h sh is the name of the batch script. And I'm going to open it just for a moment and show you here. Again, here I did set the path, which I failed to do in the other one. And that means that this should be able to run as soon as you change my dear name to the name you used when you created a directory under the storage directory here. So I would need to change this to my name. Like that. So here we are running on Snowy. And because of that, I need to add Snowy here when I check how it's doing. And it's pending, as you can see. I will just also start it on HPC2N, and then they can both sit in line and wait to run while I continue. And as you can see here, one thing to note is that on HPC2N, you are loading the PyTorch that runs with CUDA. And on UPPMAX, you load the Python ML packages also. And this example here is run as an interactive Snowy session here, but you can also run it as a batch job. So you could try both if you want to. And the advantages with doing it as an interactive session is that, well, you can see what is going on directly, and you can change which modules you load if you want to test something, of course. And when you do have the interactive session, if you have several jobs that you want to run, then you can just run them immediately instead of waiting between each one of them. So in that way, it's easier. This is still pending. So it's pending due to lack of resources. So I'm guessing that a lot of people are running stuff on our reservation right now. And the one at HPC2N is also pending. So I will continue and return when this hopefully soon gets to run. So the TensorFlow, the examples are from this page, and you can also find good examples on this one here, TensorFlow's tutorial page. And in this case, I am using a different Python version than I've been using otherwise. I'm using 3.10.4 at HPC2N for the reason that there is no CUDA-enabled TensorFlow installed at HPC2N for Python 3.11. On UPPMAX, the TensorFlow is 2.15. Which is the one that is included with the Python ML packages for Python 3.11.8. And let's try this. And since you also need scikit-learn on HPC2N, you need to also load the scikit-learn. So here you would load these modules here, and I have done so in the example batch script. So you see here is the one that's prerequisite for the Python, and OpenMPI is a prerequisite for the TensorFlow. So both of those are. The TensorFlow module will actually load Python as well, and it will load CUDA, and then I load scikit-learn for a compatible version with these ones. At UPPMAX, Python 3.11.8 and Python ML packages for 3.11.8 should work well. So that can just be used. Nothing else is needed there. So this is the example batch script on HPC2N. And just one moment. This here, if you want to look at it, that is the example, TensorFlow example that we're using. It's called example minus tf.py. And you can see this is the one that we're running here. And let's see if anything is happening. Meanwhile, the PyTorch example has run. And that one had output files. And the output is here in this one, job file. And this is the output you got. And if you go up and look, then you can see that it is similar to what you got when running it directly. Okay, let's try and run this on UPPMAX. It's this one here, example minus tf.sh. I will open it, and this time I will open it with nano. And then I will go down and change this path to my own name here, the name of my directory I created. So remember to do that. And when that has been done, you can save it and then submit it like this. And again, it's submitted to Snowy. So you need to add that like this. And it's running, so that's good. And for HPC2N, it's the exact same thing. So I will just start it here on UPPMAX now, and then because there is a longer queue for the GPUs on HPC2N. We don't, there is a lot of people using them right now, but we are getting more hardware tomorrow actually, so we will get more GPUs, so that is good. It's arriving then, and then we will have to install it and test it, but soon anyway. This has run, and it is this one, I believe. And I made some mistake. Let's see what that was. No. No, there's no mistake. I remember this. There was some sort of problem with the TensorFlow at the UPPMAX. I think it actually does run and produce output, but it also creates a ton of warnings. So I will try to actually run it at the HPC2N so you can see how it looks when it actually runs without warnings. So I'm just going to briefly mention what you can do if you want to run several jobs from within one job. There was the job erase example that I had on the batch, but it's also possible to simply submit it several times within the same job. And then you don't have to wait for it as long. If you know that they need say just different parameters or whatever, then you could rerun it several times with the different ones. But remember that you need to ask for enough time that all of them will run. And then I have some exercises, and there are these ones here that are continuations of the one pandas matplot one, and those you could try and make minor changes to. so they can run from a batch job, and that is the very minor change where you change plot to save to file instead, like was done up here at the beginning. Let's see, you know, where you change it so instead of the plot show, you get a plot.save figure and the name. That is actually the only thing you need to change in those. And then you could also make a batch script for both of them. And that could simply be a minor modification of the batch script that was further up on this page. And then there is another exercise that you could look at. And that is the simple lightgbm.py example. And that is the one where we installed to a virtual environment. So here we will be using a virtual environment. And this is the code that will run. And there are two solutions here. And I suggest that you try to do it yourself first before you look at the solutions. So, and before we go to that, I will just briefly go through what the key points of this was. At all the clusters, you will probably find PyTorch, TensorFlow, and scikit-learn, and also many other machine learning packages. They will be installed at most of the HPC centers in Sweden. And the only thing that's different is that the loading will be slightly different. And there will also be slightly different versions. But again, as you saw under the loading and running section, you can check with the module spider and other things to find out which versions and which tools are available and what they are called. So, but I think you should try and run some of these type alongs, and I definitely think you should try and also do the exercises if you have time. And there should be some time now. So at least maybe we could take 10 minutes at least and do this.